The final thing we're going to do with our z-scores is actually use our table in reverse. And this is where we talk about percentiles. Okay, a percentile, the kth percentile, is the value for which k% of the data observations are less than or equal to that value. Okay, so for example, if a test score is in the 70th percentile, okay, suppose I took a test and I know that my score was the 70th percentile. That means that 70% of individuals scored less than or equal to what I scored. Okay, so that's what a percentile is. That's really just those values in the table, okay, the z-score table. So let's go ahead and apply it. Suppose that the wrapper of a certain candy bar lists its weight as 2.13 ounces. The weights of individual bars vary, and so we're going to suppose that they vary according to a normal distribution with mu equals 2.2 ounces. That's our mean. And our standard deviation sigma equals 0.04 ounces. And we'd like to know how much does a candy bar in the 80th percentile for weight weigh. So I'm going to draw a quick sketch here. I've got a normal distribution, and I have the 80th percentile. That means that I've got some value over here where to the left of it, I've got 0.8. That's my 80th percentile. So I am going to look in the chart. I'm going to find the z-score right here. I'm going to look at the chart for something that has a 0.8 as my entry. Okay, so I'm in my chart, and I'm in positive because I know it's bigger than 50%. So I'm looking, and I'm looking in these numbers here, okay? I'm looking for the closest thing to 0.8 that I can. And notice that I've got right here, okay, is somewhere, so it's bigger than 0.7995, okay, but smaller than 0.8023. All right, so I know it's somewhere in between here, okay, so that's a z-score of 0.84 or 5. Now it's a lot closer to this, so I'm actually going to use that. I'm going to use 0.84, okay? And that's my z-score, 0.84. Okay, now I can go backwards and I can find my x value. So I know that z is equal to x minus mu over sigma, and I know everything except for x. And you may want to use the formula x equals mu plus z times sigma, okay? Anytime you're solving for x, which is what we're going to be doing anytime we have percentiles, okay, and we're trying to find the data value, we can use this formula here. So x equals mu, which is the mean, 2.2, plus the z-score I found, which is 0.84, times sigma, which was 0.04. Now notice that my answer here is going to be an approximation because I had to approximate that z-score, okay? You can use software or online calculators and stuff to find that exact z-score, but we're not going to worry about that. So I get 2.2336, and this is in ounces. Let's look at another example. The distribution of weights for newborn babies is approximately normally distributed with a mean of 7.4 pounds, that's mu, equals 7.4, and a standard deviation of 0.7 pounds, that's sigma, 0.7. A baby is born at the 35th percentile. How much does the baby weigh? So I'm going to go ahead and draw a quick picture here. I've got my bell curve. I'm at the 35th percentile. That means I'm somewhere where I've got 0.35 to the left. Okay, and I want to find this z-score here. So I'm going to go to my table, and I want to find 0.35 or close to it inside my table. So I'm going to go until I find something that looks like it's pretty close. So 0.35. It's looking like it's down here somewhere. Okay. And here we go. It looks like it's right between these two things here, 0.3520 and 0.3483. And it's not super close to either one of them. It looks like it's pretty much about halfway between them. So what we're going to do This is negative 0.38. Okay, up here I've got my 8 and 9. Okay, so negative, 0.38 or negative 0.39. Now it's about halfway between, so we're going to take the average of these, and the average of those is negative 0.385. Okay, because it wasn't significantly closer to one of them. And so we're just going to take the average of the two. So that's my z-score. And then we're going to find the x value. So we know our relationship is z equals x minus mu over sigma, or you can use the formula x equals mu plus z times sigma. So I'm going to go ahead and use that. X equals mu is 7.4 plus z is a negative number, negative 0.385. And times sigma, which is 0.7. And we get 7.1305. And that's in pounds.